If you have ever been part of a major project, you know for a fact it rarely goes exactly to plan. Right behind all those schedules and meticulously planned milestones lies the ultimate strategic puzzle, and that is human behavior. Today, we are going to explore how looking at project management through a mathematical and strategic lens can literally change how you handle your next big project. Okay, let's start today's session with a question. Why do so many perfectly planned projects inevitably descend into massive budget overruns, endless delays, or worse, bitter lawsuits? It usually isn't because the engineering was flawed or the software just gave out. It happens because people executing the project are operating with completely different playbooks. To really understand this, we must look at the underlying motivation of everyone involved in a project. I want you to think of a construction site or a corporate office not just as a workplace, but as a giant multiplayer game. And in this game, everyone has distinctly competing goals. You have got owners pushing for absolute lowest possible costs. Meanwhile, contractors are trying to maximize their profit margins. Subcontractor, they just want to get in, do the work, and get a quick payout. And then you have regulators who are demanding zero risk and total compliance. When you throw all these self-interested players together in one environment, friction isn't just possible, it's practically guaranteed. So how exactly do we make sense of all this chaos? Well, here is a roadmap for today. First, we'll see why projects are multiplayer games. Secondly, we'll look into the two ways in which this game is played. In third section, we'll dive into bidding and contract designs. In fourth, we'll cover negotiating conflicts and disputes. And finally, we'll do a quick reality check on the pros and cons of this whole approach. Alright, let's start with the section 1. To really examine this complex stakeholder behavior, we need a solid framework, and that framework is a game theory. By definition, game theory is formally study of strategic decision making among independent, rational actors. Researchers point out that this applies perfectly to project management. You might be thinking, why is that so? Because anytime our outcome depends on the self-interested choices of somebody else, guess what? You are playing a game. Every single decision you make is contingent on what you think the other person is going to do. Let's move to section 2. 2 ways to play. Cooperative versus non-cooperative games. There are essentially 2 core games happening on any given job site. On one side, we have non-cooperative games. This is where each party independently pursues its own payoff, leading to what's known as Nash equilibrium. Basically, it's a state where no player can improve their position by changing their strategy alone. It's all about fiercely protecting your own slice of the pie. On the flip side, we have cooperative games. These use models like the Shapley Value and Nash bargaining. And this brilliantly illustrates the alternative, players forming binding coalitions to share risks and rewards, actively working together to grow the overall pie, and then divide it up fairly. Now let's jump into section 3 that concerns bidding and contract design. The first move, the inception phase of a project, is arguably the most naturally game theoretic setting of the whole context. Because the precedence you establish right there dictates absolutely everything that follows. The crucial concept to grasp here is the winner's curse. Think about competitive bidding. The contractor's strategy is pretty much entirely based on guessing their competitors' moves. If you guess low just to win the job, you end up with underpriced bid, but you still need to make a margin. Isn't it right? So that artificially low bid inevitably leads to downstream cost overruns, aggressive claims, and cutting corners. It's a classic non-cooperative scenario where opportunistic bidding literally poisons the well from the day one. But here is the good news. We can fix this by changing the rules of the game. Recent literature shows that when you combine procedural reforms with better contract design, you shift the equilibrium right away from opportunistic behavior. For instance, Just moving from a standard low bid auction to an average bid auction completely discourages those impossibly cheap proposals. Combine that with stronger project manager oversight, and you actively deter corner cutting. You can even use those cooperative bargaining models we talked about to structure material procurement negotiation that ensures both parties benefit from efficiency rather than just endlessly squeezing each other on price. Now it's right time to discuss section 4 that concerns navigating conflicts and disputes, predicting the opponent's moves. Let's be real. Even with the absolute best contracts in the world, execution gets messy and delays inevitably spark conflicts. When a dispute hits, the players enter an escalation ladder. Negotiate, mediate, arbitrate, or litigate. Now, game theory gives us a really powerful way to navigate this ladder. By mathematically weighing the anticipated costs and the probabilities of success at every single step, these models can actually map out an opponent's likely moves. This is huge because it helps predict manager identify settlement zones earlier on. So instead of reacting emotionally to a conflict, you logically deduce that settling at step 1 or 2 is mathematically way superior to dragging the whole thing into a courtroom. And honestly, this isn't just some academic theory. A major study conducted in 2025 looked closely at this exact escalation ladder. The study validates this game theoretic negotiation framework across 20 real-world construction conflict scenarios. And what they found was that applying these strategies actively supported achieving win-win settlement long before those conflicts overreach formal, incredibly costly arbitration. These models also solve some massive logistical headaches. For example, figuring out how to allocate penalties and rewards across different project members can be formalized using cooperative models. Those Shapley's value models I mentioned earlier, they are incredibly effective for calculating exactly how to share cost burdens in public-private partnership and joint ventures. Furthermore, non-cooperative models can actually calculate something called the price of anarchy. This is literally the exact efficiency loss you suffer when independent project agents act selfishly instead of following essentially optimized schedule. It puts a real tangible number on bad behavior. Now let's turn to section 5, which concerns reality checks about game theory. Now, all the discussion on game theory sounds absolutely fantastic on paper, but we do need to address where these mathematical models fall short in the messy real world. Now, what's really interesting about this breakdown is the stark contrast between rigorous diagnostic power and human nature. The advantages are, of course, significant. You can anticipate opportunistic disputes, design bulletproof incentives, and completely preempt litigation. But game theory assumes players are fully rational, totally emotionless, and purely profit-driven. Let's face it, humans rarely are on top of that. Utility functions like someone's reputation is incredibly hard to quantify with math. And once you are dealing with a massive multi-party mega projects, the math becomes overwhelmingly complex. Plus, these static models often completely miss the immense value of long-term trust and repeated relationships. This actually leads to a really critical consensus in the academic literature. Reviewers constantly note that game theory functions best alongside other project management decision tools, rather than as a substitute for them. So no, you don't throw away your Gantt charts or your budget sheets. Instead, you pair the strategic mindset with conventional tools like Monte Carlo simulations for risk or real option analysis. Think of it as a super-powered enhancement to your existing toolkit, not a replacement. So what's the big takeaway from this section? Basically, game theory is a highly structured way of reasoning about interdependent decisions. It's not some standalone crystal ball that's going to flawlessly predict the future. Its true power lies in forcing you to put yourself directly in the player's shoes. It helps you understand their incentives, allowing you to design a project environment where cooperation is naturally just more profitable for everyone than conflict. The next time you are sitting across the table from a contractor an owner or a regulator, just remember that their moves are totally dictated by the rules of the environment you are sharing, which leaves you with one final, very important question to ask. Are you managing a project or are you just playing the game? I really hope today's session gives you a complete new perspective on your next big venture.